Now that we've seen a basic example of how a unit test is carried out in GeneXus, we'll be considering a couple of more advanced examples that include interaction with the database. We'll start by a procedure that queries the database but does not update it. We have a procedure called doLoadCountries. This is a service we'll use in feeding the various country reports in the app. The service receives an SDT called Country Report Options as entry parameter. This SDT includes a member where we define the filters by which we select the countries. For the time being, we'll only do it based on the minimum number of attractions that we want the country to have. There's another element called sort criteria where we may define an order criterion. This is an enumerated element allowing us to return the country list ordered by name or by number of attractions. The service then receives a filtering criterion and an order criterion and returns a variable called SDT country collection, where the collection of countries that fulfill the filter specified is located, and it's ordered by the filter selected. The interesting part of implementing this service is that we may perform automatic unit tests that validate the fact that data from reports is correct in all the scenarios we deem relevant for testing. Then we program the reports using this service as our data source instead of accessing the database directly. At the time of testing, this provides us with confidence as to the accuracy of the data reported thanks to the unit test we did previously. And all we need to do is verify that the report format is correct. This example shows a greater complexity than what we find in the discount procedure, because the input and output parameters are SDTs instead of simple data. Therefore, the load of test cases will imply a little more work, and also, because in this case we'll be accessing the database. So, at the time of deciding which values to test, we must know the database that we're testing. Let's now create the unit test, and then we'll continue considering these concepts as we move on. Something important to point out is that objects created for the unit test are nested under the object to be tested, and they're not generated when we do a build all of the KB. They're generated only when necessary to execute automatic tests. The fact that they're nested under the procedure simply means that, if we delete the procedure, the associated tests will also be deleted. Objects are not synchronized in the sense that, if we modify the input or the output parameters of the procedure doLoadCountries, we'll have to update tests manually as well. And in fact, we'll have to think of the impact of the changes in the input and output parameters in our test cases. And in relation to test cases, in order to execute our unit test, the first thing to do is define the test cases, or at least one test case with which we'll try. We'll see the data provider generated automatically, and we know that it's somewhat different than the one in the discount case, where all input and output parameters were simple. In this case, with SDTs, the data provider automatically generates a structure that we must complete. To do that, we may take and drag the SDTs so as to bring the SDT structure to the data provider as we always do. Or, in this case, because it's simple, we have the option of writing them. In our first test case, we'll do a test useful for the report that shows the countries with more than 2 attractions, that returns them showing the countries with a greater number of attractions on top. In order to define the values expected, we have 2 options. One is to go to the database and analyze the values to then enter them here in the results of the test case. Alternatively, what we'll do now is to execute the test with an empty expected result, which, as we already know, will fail. We'll see the result obtained, and we'll validate it manually, and if we're satisfied with those values, we'll copy them as the expected result. The interesting thing here is that we can take a photo of the procedure's result with certain input values, and if the procedure is modified in the future, we'll have an easy way to know if nothing was broken. That is, if the same output or the same report data is generated for the same input data. Make sure you're aware that it's very important to know the database on which we're testing, and also to have a stable database to execute the tests, so as to avoid having tests that fail due to changes in the database. As expected, the test fails. Now we don't see the value expected and the value obtained in the test results screen because the result of our procedure is an SDT, handled here as a JSON in order to compare it as a string. To view it in detail, we have the option of expanding the result and seeing it in a text comparer. In our case, we see that the result obtained is that France and China are the countries with 2 or more attractions. The value expected is blank because we didn't define it. If we verify that these are the correct values, we may now set this information as the expected result in our data provider. Here, we can copy and paste the info to the data provider, though the result format is a JSON, so we'll have to change its structure to the correct one in our data provider. We'll execute again, and now we know that our test will be successful. We can go on adding test cases. In this case, the procedure is very simple, so we could add a case to test another order criterion and perhaps an empty filter. In a more complex case, with more filtering criteria, we'd probably need a richer set of tests. We won't see it in this course, but there is a way to skip the database so that, provided that nothing changes at the tested procedure level, the execution takes place against a saved state of the database, though not against the actual database. This is known as data mocking. You'll find further information on this in our wiki. Now let's take a look at a second example where we'll be testing a procedure that makes changes to the database. To do this, we'll see attraction insert, a procedure that inserts attractions in our database. This procedure receives as parameters a data structure with the information about the attraction, then it does the insert, and then it returns, as a result, a data structure with a result code and a message, in addition to the ID of the attraction created. Let's take a look at this procedure's implementation. Something important to consider is that the procedure uses a business component to do the insert. So, when we test this procedure, we're not only testing the procedure itself, but the rules we define in the business component as well. To create the test, we do the same as usual. Right-click and select Create Unit Test. Then, we'll define the test cases as we always do. The input parameter in our procedure was an attraction SDT, so, since we don't remember its structure, we'll look for it in the KB, and we'll click and drag it to bring the structure here. Then, we complete the values according to the case that we want to test. Our first test case will be the happy case, which means that we'll use valid values so that a new attraction is successfully included. And we'll do the same for the expected result, which in this case is an insert response. So, we'll bring the insert response structure to the data provider. And here we define what we expect. The insert response structure has a result code, which in our case, we expect that it'll be successful. This will be a message that, if the insert is successful, will be empty, and the ID of the attraction that will be inserted. Note that here, we leave it empty because the ID to be assigned is an auto number, and we can't tell in advance the value that will be assigned there. If we executed this test and assigned a value to it here in the data provider, then the test could function on its own the first time, if we knew the next auto number to be assigned. But the second time we would try to execute it, the auto number would be different, and the test would fail. So, to avoid that problem, we'll have to modify the unit test. In that sense, what we'll do is, after invoking the attraction insert procedure and obtaining a reply, we'll modify our expected value with the value actually obtained. This will ensure that the values will always be the same. That is, the value expected and the value obtained of the ID will always originate in the same place. Therefore, the assert of only that element will be a pass. But we're interested in the rest, which is the result code and the message. Now we'll execute our test. And while that takes place, we must take note that the only thing we're validating in this test, the only thing on which we're doing assert, is the result code and the message returned by the procedure. But we're not actually validating that the information is duly recorded in the database. To do that, we must modify our unit test in order to add an assert that is verifying the data expected. Now we can execute our test again. And we know that we'll be validating the data in the base. Note that our test failed. The fact is that a single key exists for the name and the country of the attraction. So, we must include some sort of variation in the attraction's name in order to execute this test as many times as we want. To do that, we'll just assign a timestamp to it. Now we can execute our test again, and this time it'll be successful. We can see that we have several asserts, or several results, one for each assert done in the unit test. Now that we have our first test in operation, we can continue adding new test cases. For example, to practice any of the validation rules in the transaction, we can see that in the attraction transaction, there's an error when the name of the attraction is empty. So, we could create a test case to practice that rule. Here, we already added in our data provider a new group of the test cases to test this new case. So we leave the attraction name empty, and in the result code, we indicate that we expect a failure. In the message, we put the message of the error rule that's not this one returning the transaction, in this case the business component, and in the error message, we indicate that we expect a failure when the name of the attraction is empty. Let's then execute our tests. Something we can see as our test is executed is that, among our asserts, we have a for each that always awaits for a new attraction to be entered, and this will not only be the case. In sum, in this second test case, we actually expect the business component to pick up an error and that no insert takes place. So we can already know that, since our test is not correct, it'll generate a false positive, indicating an error where there isn't any. What we have to do is fix our unit test for it to do the correct asserts. In sum, what we'll do is validate the data on the table only for the case when the insert has been successful, and we'll force a fail in the case of a record in the database when the code of the result of the insert event has not been okay. On the other hand, we'll force the failure in the when none only when the result code of the insert is okay, because in that case, we expect the record to exist. Here we're doing the if against the result code obtained upon invoking attraction insert. However, it would have been the same to do it with the expected result code, since we previously did an assert validating that they were the same. If they were not, our test would have failed there. So far, we've seen a couple of examples on tests for procedures that interact with the database, and we also saw the process that would aid us in creating and perfecting our tests. This is useful to us as we develop, for validating the functionality we implement. But, as opposed to when we worked with a screen or messages on the console for testing, the time used in developing the unit tests will now capitalize our KB, because unit tests will continue to be executed repeatedly, thus becoming part of the regression testing. Tests can be uploaded to the GeneXus server, and they may be executed in different environments, to the extent that we have a known database, or if we use mocking. Note that, after tests are shared on the server, the GX test license will be required. For further information on licensing, check our wiki. What's interesting in sharing tests and keeping them on the server is that we can automate their execution as part of the continued integration process in Jenkins. So, we can avoid publishing a version when errors are encountered, and for quickly alerting the team in that respect, so that the problem can be promptly solved with lower costs as well. In our wiki, you can find further information on continued integration, and on how to integrate unit tests in Jenkins.